All right, this unit is all about factoring and solving something called a quadratic equation. And we get a little bit more into it in our very last unit of this semester, but this is like the intro to it. And the main part of this, and this is an incredible skill that you have to know, especially if you're going on to further math from this, maybe pre-cal 1, or I don't know if you do it into quantitative reasoning, but I'm not sure. But definitely pre-cal 1. So that's 1513, is factoring. All right, and the first part of factoring is something called a greatest common factor, which is the largest possible factor that terms have in common. So talk about a factor in and of itself. A factor is when you multiply two or more numbers together. So 3 times 2, which is 6, that's 3 and 2 are both factors of 6. 3x squared times 5x cubed, which is 15x to the 5th. 3x squared is a factor, and 5x cubed is a factor, because when I multiply them together, I get 15x to the 5th. 2x minus 3, x plus 4. You get 2x squared plus 8x minus 3x minus 12. So that means that 2x minus 3 and x plus 4 are factors of 2x squared plus 5x minus 12. Because when I multiply them together, I get 2x squared plus 5x minus 12. So to start off, we're going to talk about just a common factor. A common factor is just any number that can be divided out of the terms. Okay, you're undistributing your function, your expression. So looking at example 1, I can see I have 3 and a 6, and they can both be divided by a 3, which means 3 is a factor. If I divide that 3 out, okay, you don't have to write this down every time. I'm doing it here though. 3x by 3, that's x. 3 goes into 6 twice, so that's 2y. And this means that 3, Heather, that's big. 3 times x minus 2y is 3x minus 6y. When you redistribute, 3 times x, 3 times negative 2y, we get back to the original. So it means 3 is a factor and x minus 2y is a factor. Okay, so I don't have any numbers in common for this particular expression, 9x plus 2y, because 9 and 2 can't be divided by the same thing, but I do have a variable in common. And that variable is x. So I'm going to take it out. You don't have to write this down every time, but if it helps, do it. Basically dividing. So if I divide 9x by x, that's 9. 2xy by x, that's 2y. So that means that x and 9 plus 2y are the factors of 9x plus 2xy, because if I multiply them back together, it results in the original function. 21a minus 7b. So I don't see any variables in common, but I can see that 21 can be divided by 7. So 7 must be the common factor. So it's 3a minus b. So that means that's 7 times 3a minus b. These are the factors of 21a minus 7b, because if I multiply them back together, I end up with the original. No numbers in common here, but I do have a variable. Got the x. So that leaves me with 5y. That is plus 8. So x 5y plus 8. These are factors of 5xy plus 8x, because if I redistribute, I end up with the original expression. Now, greatest common factor is the largest possible numeric and or variable factor of an expression. So it's the biggest thing that you can divide out. So if I were to ask, is 2 the greatest common factor of 16x minus 8y? Well, if I factor out that 2, so if I take 16x divided by 2, that's 8x. Take 8y divided by 2, that's 4y. And then we look and see what's left, and I can divide again. So 2 is not the GCF. So if I consider what the actual GCF is, I can divide both of these by 8. 8 goes into 16 twice. And 8 goes into itself once. So 8 is your GCF. Now, in terms of your variables, I want you to underline this or highlight it or whatever. GCFs for common variables are the smallest exponents of the variables. They have to be in common, but they're the smallest exponents of the variables. All right, on example 5, I've got this whole expression here, and I've got, for my coefficients, 24, 12, and 36. So typically what I would do first is see if the smallest number, so 12, can divide evenly into 24 and 36, and it does. Then the next thing I'm looking for is common variables. All right, xy, x squared, x cubed. So they have a common x. We're looking for the smallest exponent. Okay, so I have x to the 1, x to the 2, x to the 3. So my smallest exponent, x to the 1. So x to the 1 is my greatest common factor. So if I divide, so I'm not going to write it out this time. We can use my laser. 12x. So 12 goes into 24 twice. X cancels x, so it leaves me with 2y. Divide here. 12 goes into itself once. That's an x to the 1. So we're going to subtract it from the 2. So it leaves me with just x. Twelve goes into 36 3 times. Again, x to the 1 here. So I'm going to subtract it from x cubed. So that leaves me as 3x squared. If you did it right, you should not have any repeating, like common variables inside your parentheses. So what this means, 12x times 2y plus x plus 3x squared. If I redistribute, these are both factors of 24xy plus 12x squared plus 36x cubed. If you were to redistribute, you would get the original expression, which I do. 12a squared plus 16ab squared minus 12a squared b. So the smallest factor there is 12, and it doesn't go into 16. So I need to think of something else there. Not 8, because 8 doesn't go to 12. It's 4. So 4 is the smallest one. And let's see, I do have a's. So it's going to be the smallest exponent. All right, so 12a squared by 4a. So 4 goes into 12 3 times. That's a to the 1. So 3a. Four goes into 16 4 times. A cancels a. So 4b squared. So 4 goes into 12 3 times. That's a to the 1. So subtract. So it'll be 3ab. So now that I factored it out, 4a and 3a plus 4b minus 3ab are factors of the original expression, because if I redistribute, (16ab squared), that's negative 12, and then a times a is a squared b. We end up with the original. Okay, I'm kind of messing with you on this one. Pi is a number. Okay, so they share 4 pi. They also share a common variable with r. So it's the smaller exponent, so just r. So if I divide by 4 pi r, 4 cancels 4, pi cancels pi, r cancels r, so that leaves me with h. Four cancels 4, pi cancels pi, that's r to the 1, so we're left with just r. I was messing with you a little bit on this one. Not particularly worried about that one. Let's look at our last one. Sometimes can't factor out anything. X squared, y squared, 3x squared, y cubed. No common factors. Nothing in the front because it's all 1s and 3s, so this is prime. Remember, a prime number is a number that can only be divided by itself and 1. And itself doesn't count as a GCF. Okay, let's take an example 9 for GCF if 16 and 24 is 8. And then I have a cubed and b cubed, so no common variables. So again, we imagine dividing. Give me the, thank you. 8 goes into 16 twice. 8 goes into 24 3 times. Okay, got a bunch of r's. R cubed, r to the 4th, r to the 5th, so r cubed. All right, so r cubed, so that's going to cancel and leave s squared. So we're going to take it away from the 4, so that's 4rs. So we're going to take it away from the 5, so 7r squared. Um, 8, 16, and 24, so that's 8. And looks like we have x's and y's, that's fun. Okay, so y's, so x's, I've got x cubed, x squared, so x squared. And then for y's, y squared, y cubed, so y. All right, so 8x squared, y, 8 goes into itself. And then subtract, and then y cancels y, so just have x. So 8 goes into 16 twice. X squared cancels x squared. That's y to the 1, so I have 2y. Eight goes into 24 3 times. Subtract. So that's 3x y squared. Oh gosh, 9 I think. 18, 20, yeah, 9, 18, 27, and 45 are all divisible by 9. And let's see, a cubed, a squared. So a, looking for that smallest exponent. b squared, b cubed, b squared. So b squared, I don't care which b squared you highlight though. C squared, c squared. So c. Nine goes into 18 twice. That's 8 to the 1. B squared cancels, c cancels. So that leaves me 2a squared. Okay, 9 goes into 27 3 times. A cancels a. Subtract 2 from 3 and 1 from 2. So that's 3b c. Nine goes into 45 5 times. A, b cancels, subtract. All right, so that's 5a c. Okay, I want you to highlight this one or underline it or bold it, whatever. Because something happens on this one that you need to be really cautious about. So first, I have 9 on both coefficients, so your GCF is 9 there. And it looks like my lowest x1 for A is 2. Lowest x1 for B is b squared. Doesn't matter which b squared, they're the same. All right, so 9a squared, b squared. 9 cancels 9. That goes down by 2. B cancels b. B squared cancels b squared. So we just have a. So this is what I want you to watch out for, is this piece. So what happens is 9 cancels 9. A squared cancels a squared. B squared cancels b squared. Okay, so what that really means, okay, but kind of put that aside for just a minute. If I asked you what 4 divided by 4 was, that's 1. Well, another way to write this is 4 over 4, also 1. So if you're dividing something by itself, it's 1. So if I'm dividing 9a squared by, or not, let's try that again. I'm dividing 9a squared b squared by 9a squared b squared. Yes, it cancels, but what it really does is reduce to 1. So this piece right here is what I want you to pay the most attention to. 9a squared b squared divided by itself is 1. All 3 terms can be divided by 6. And it looks like x cubed, x squared, x, y squared, y squared, y squared. So y squared, it doesn't matter which y squared, so don't get all picky with me. 6xy squared. Let's see, 6 goes into 30 5 times. X to the 1, y squared goes, so 5x squared. Six goes into 24 4 times. That's x to the 1. Y squared cancels. So 4x. 6xy squared. This is another one I want to pay attention to. 6xy squared divided by 6xy squared is 1. All right, so I'm introducing this idea of a common binomial factor here, and we use it later on. So a common binomial factor, okay, is like an expression that you can factor out. And you can kind of see it as an expression inside of the expression. So what I mean by that is that I have this thing happening right here. And I have 2 separate terms. I have the x and the times x minus 1. And I also have the 3 and the x minus 1. But inside each of those, they have the x minus 1 in common. That is called your common binomial factor. Okay, so if I imagine from dividing by that x minus 1, just like it did in the previous parts, x minus 1 cancels, and you have an x left. Okay, doing the same thing over here, we're dividing it by an x minus 1. X minus 1 cancels, and you have a plus 3 left. Okay, so let's look at this one. The common binomial factor, x minus 4y. Okay, so if I think about it, x minus 4y cancels, and we have 3x left. X minus 4y, 2 is left. And example 16, a plus 5b, a plus 5b, that's my common factor. After dividing by it, leaving you with the 3. Leaving you with an x. Now, these previous two examples, that second, or even the first, they all had something in front of our parentheses. What if it doesn't have anything? Okay, well, before you find your common binomials factors, you put a 1. And I can see the common binomial factor, 9y squared minus 2. So again, imagine 9y squared minus 2, common binomial factor, leaves you with 8y. 9y squared minus 2 leaves you with the 1. Okay, that one has something in front of the parentheses, but this one doesn't. Go ahead and put that 1 in front of it. Common binomial, 2x minus 3y, 2x minus 3y. Again, if we imagine dividing, 7x squared and minus 1.